We're only working with one sample. We're comparing it to the population. So we'll click one sample t-test. You're presented with this pop-up window as we get into the habit of being more familiar with conducting these analyses. You're going to find that you'll often be presented with somewhat familiar looking pop-up windows to help you navigate, conducting your tests. So because we are comparing our sample age against the population, we want to make sure that that is the variable that we are running our test with. I should have emphasized a moment ago, but I'll do it here, that in order to be able to compare our sample to our population, because we're talking about population mean and sample mean, that suggests that our variable needs to be a variable that we can calculate the mean for. Now we can calculate the mean for scale variables, right? If I ask how old someone is and they report that they are 20, I can add that age to someone who is 30, add them together, divide by 2, and come up with 25 as an average age. Remember that that's what the average is accomplishing. It's taking every data point that we have for this particular variable, adding them together and dividing by how many there are. So when we are selecting which variable we want to work with for a one sample t-test, we are only looking for one scale variable. It has to be a variable that we can calculate an average for. We cannot calculate an average for a nominal variable. We can't add together, if we're asking questions about people's political party affiliation, we can't add together someone who is Democratic to someone who is Republican and divide by 2 and determine something, right? So you want to make sure that you're not using a nominal variable here. Ordinal variables, you might think that it would make sense because in some cases an ordinal variable can calculate a mean, but remember that the means don't necessarily carry any kind of significance, particularly within SPSS. So that is to say that when we are working with the one sample t-test, you want to make sure that the variable you're using is one that you can calculate a mean with, which is to say a scale variable. Okay. All right, so we've got our age variable here, and this is where we're saying this is the variable we want to use. This test value window, or this test value box rather, is where we are going to place the population information that our sample is going to be compared against. So a moment ago I mentioned that the average community college student age in the United States is about 28 years old. So we're going to select this test value box and place the number, the population number we're comparing against. I want to point out something here in this options window. I'm not asking you to make any modifications to the information found within this options window, but I did want to show you something about confidence intervals within here. Now, I've mentioned several times throughout these last few weeks that the confidence interval is where we as a researcher are determining where it is the boundaries for our critical regions exist. Now, we can work at 95%. That's very common. 99% is another very common confidence interval range percentage. But you want to keep in mind when it comes to you as the social scientist, right? So outside of the context of this classroom, when you are the one who is deciding the appropriate confidence interval for your test, you may think that, okay, I want to be most confident. I want to make sure that, if I'm finding some sort of significance, that there truly is that kind of significance. You have to weigh that against the likelihood of committing a type 1 error. Remember that type 1 errors are when you are rejecting a null hypothesis and you're saying that there's a significant difference when in reality there isn't one, right? That's that type 1 error. And so by selecting an alpha level, and remember the alpha level for 95% confidence is an alpha level of 0.05, it may seem, you may want to kind of lean on this idea of, okay, well, let me just shrink that alpha level. Let me reduce the likelihood of making a type 1 error. But then you are asking for so much more evidence from your test in order to demonstrate significance. So you have to weigh those things out, right? That's the responsibility of the researcher, whether on your own or as part of a team. The point is that you will have to make that decision and have a rationale behind it, right? It's not just you're kind of out here just making whatever decision feels good on a Tuesday, right? You have to have a rationale that makes sense, that you can back up through other research that's been done in the similar area, or just getting a sense of how other professionals may be using confidence intervals within your particular field. So while we could change the confidence interval percentage here, we're not going to. So we'll go ahead and cancel this. Okay, so again, just to emphasize, we are testing our sample age against the population age of 28. And we're wanting to know whether or not there's a significant difference between our sample and the population data. When we click OK, just that quickly, SPSS is already done. Notice in this first table here, the one sample statistics, we have the information that we kind of drew from that group statistics table previously. We have our N of 1,037. That's how many people participated. We have our average again of 22.55. Our standard deviation of 6.06. I'm highlighting those in particular because I'm going to see if I have a tool that allows me to highlight here. All right, so unfortunately, I don't have a tool that allows me to highlight. So, I'll move slowly as I'm emphasizing different data points on this output. So the data that I'm going to be highlighting, and as we're taking a look through these through this output, are data that's going to be incorporated into your reporting results section, right? The idea being, after you work your way through the t-test PowerPoint, after each test, or within the context of each test, the one sample, independent samples, and dependent samples, I provided you with about 2 to 3 sentences of APA formatted results as it pertained to the examples that I was providing. So I'm emphasizing that because when you are drawing your information from these outputs, you want to highlight for yourself what information is necessary to make sure that when you go to complete your reporting results section, that you have all of the data that's necessary. All right. So I won't be bringing up the PowerPoint here while we are together, but I am going to highlight the different data points that you want to make sure you are incorporating into your reporting results section. So the N is not necessarily a number that you have to report within your reporting results section. You can if you want to, right? And you would make reference, in this particular case, you would make reference to the sample containing 1,037 participants. But you would incorporate the mean, right? And so if you can think back to the PowerPoint, that's where in parentheses we saw capital M, space, equal sign, space, and then the mean, right? And so here we would report 22.55. Then there was a comma, space, SD for standard deviation. That's the second data point here. Space equals space. I'm emphasizing these spaces because they are appropriate for APA formatting. And then you would incorporate 6.06, and then you would close that parenthesis. So that's you saying, here is my sample, and this is the average age, and this is the standard deviation of that age variable. We don't need the standard error mean as part of reporting those results. You do need, moving down here to this one sample test table, we have the T ratio for this analysis, and this is for our data, right? So the T ratio was negative 28.98. You have to remember that, if you make your way back to that PowerPoint, I wrote that little formula at the very bottom underneath each paragraph that highlighted what information needed to be changed based on the information you had. And so it opens with a lowercase t parenthesis. Within there is the degrees of freedom, which we can see from this table is 1,036, close parenthesis, space, equal sign, space, and then that next value is the calculated t ratio, and there we would incorporate negative 28.98, comma, and then we have p. So that p is always going to be there. However, and I should have made this modification on the PowerPoint. I wrote a greater than sign in there, or rather a less than sign, excuse me. And in SPSS, SPSS produces exact probabilities, okay? So I emphasized when working through that initial PowerPoint that when you're, what's the word I'm looking for? when reporting your results, if we were doing a calculation by hand, you would keep that less than or greater than symbol. Okay, that's a little. It says it in parentheses on that slide. However, because SPSS produces exact probabilities, instead of greater than less than, you're going to have P equals blank, whatever your probability value is. In this case, as it pertains to this example of calculating this one sample t-test, we're working with two-sided P. Remember that one-sided P is for one direction one-tailed directional tests, which we are not doing in this class. So focus on the two-sided P, and you would write, well, actually in this case, you would write P is less than 0.001 because it gave us that less than symbol. If there was no symbol in front of that, we would write P equals whatever the probability